Yeah, good day everyone. I'm glad to have you back again for today's maths class. In our previous video, we talked about trigonometry, and that was the first part. You could recall all the very beautiful things we said about trigonometry in our last class. We took note of the meaning of trigonometry. We talked about the parts of a right angle triangle after we introduced a right angle triangle. And then we went on to also learn how to find missing sides of a right angle triangle. Don't forget the three parts of a right angle triangle. We talked about the hypotenuse being the longest side of a right angle triangle. We talked about the opposite being the side that is facing the angle directly, and we talked about the adjacent. Taking note of this important fact that the adjacent and the opposite cannot be identified if the angle has not been given. So we took our time to dissect all those details. In this second part, the lesson objectives have also been outlined below. The first thing is finding missing sides of a right angle triangle, which we are going to use a different approach from what we used, which was the Pythagoras theorem in finding missing sides as well. And then we're going to introduce SOHCAHTOA. Many of you may have actually heard about this mnemonic here. And then the last thing we're going to have on our radar here is finding missing angles of a right angle triangle. So come along with me. We're going to have a very interesting time out, and then feel free to like, share, and follow all social platforms. We're on Facebook, we're on YouTube, especially the videos are always hosted on YouTube mostly. So make sure you click on the link and like, share, and make the whole thing go viral. Okay, we'll go straight into what we have for the day. Finding missing sides of a right angle triangle. Recall that I said we have two approaches of finding missing side. The first one was dealt with in our previous video, which is the Pythagoras theorem. So just a recap of what we did in the last video. We said that the Pythagoras theorem is used, you can still remember what I said, Pythagoras theorem is used only when two sides are given. Only when two sides are given. Only when two sides are given. Now, who can still remember that Pythagoras theorem? It says the hypotenuse square is equal to the opposite square plus the adjacent square. So ensure you always quote the hypotenuse square first. So today we're going to look at the approach of trigonometric ratios. The approach of trigonometric ratios. Now, it is not always, in every case, you are given two sides to find a missing side. There is usually another case in which you are going to be given, let me draw it here so that you'll be able to see that. I have here, now remember that this is your right angle triangle. I have here, for instance, 30, and I have 6 here, and I have x. Now, in this case, you are not expected to use Pythagoras theorem. Why? Because two sides are not given. So when we have this kind of case, that's the second approach we're going to use now, which is trigonometric ratios. And that leads us to introducing what I call SOHCAHTOA. Now, SOHCAHTOA is a mnemonic. SOHCAHTOA is a mnemonic which stands for, your S here is sine, and this sign means opposite over hypotenuse, taking the ratio of the two sides, opposite and hypotenuse. Your C here means cosine. A represents your adjacent. YH represents your hypotenuse. While T here stands for tangent. O here represents opposite. While A here represents adjacent. Now, we have introduced the three major trigonometric functions. So we call, let's go over to this side. We call sine, cosine, and tangent they are the three basic trig functions. Please take note. Trig is the short form for trigonometry. Trig functions. And what do we use them to do? We use them to find missing sides or missing angles. That's what we call trig ratios. So for the sake of knowledge, when you're looking for a missing side, in this particular case, you will notice that only one side and one angle will be given to you. So when you have a case where a side and an angle is given, that's the angle given, then you are not allowed to use Pythagoras, you're going to use your trig ratios. So we use the trig ratios to find missing sides. Trig ratios are used to find missing sides. Please take note. Trig ratios are used to find missing sides when one side and one angle is given. When one side and one angle is given. So please take note of the condition in which we use the trig ratios, which is SOHCAHTOA. Now, how do we use this SOHCAHTOA? That's the question. How do we use this SOHCAHTOA? That's the question. Let's take a simple example. How do we use this SOHCAHTOA? Please pay attention. We're going to take a simple example illustrating this approach. Now, take for instance, we are given this. It's 30, we have 6 here, and they are giving us x. The first thing I tell students is whenever you have a problem on right angle triangles, the first thing you do is to go and label the sides. By now, we ought to have known our sides. Here is the hypotenuse. We call this side the opposite facing the angle, and we call this place the adjacent. Now, to find missing sides using SOHCAHTOA, ask yourself, which sides are given here? We have opposite here and we have adjacent here. Now, you go to your SOHCAHTOA and ask, which of these trig functions is actually holding opposite and adjacent? You see, it is tan. So we are going to put tan of that angle. Remember that tan 30 is going to be opposite over adjacent. You put your opposite 6 over your adjacent is x, and then solve the equation you have. We have that tan 30 is equal to 6 over x. You can cross multiply. X tan 30 is equal to 6 times 1. Your x tan 30 is equal to 6. If you divide both sides by tan 30, you're going to have that x is equal to 6 over tan 30. For those who have their calculator, you can press this and find the correct answer. So for this case, we are always going to be given one side and one angle, and you're expected to find a missing side. So we'll take more examples and then also buttress what we have. For instance, let me just highlight for those of you who probably may have it difficult trying to understand what those trig ratios imply. Let's assume we have 5 here, and we have 4 and 3 here, and theta is here. You are asked to find sine theta. Sine theta means opposite over hypotenuse. Opposite from your SOHCAHTOA. Let me put it here. It's always handy. Your opposite here is here. Your hypotenuse is here, and this is your adjacent. So sine theta is going to be this side 4 over 5. If you are asked to find cos theta is adjacent over hypotenuse. You put your adjacent 3 over 5. The same thing is also applicable to tan theta, which is opposite over adjacent, and it is opposite is 4, all over adjacent is 3. So this is the approach of solving right angle triangles when only one side and one angle is given. So these are the 2 cases you're going to meet in an exam, and I expect that if you're not using the Pythagoras where 2 sides are given, you're using your SOHCAHTOA where one side and one angle is given. For the purpose of this lesson, we're going to leave all this, and we're going to also handle that in the next part. And coupled with finding missing sides and missing angles of non-right angle triangles. So we're going to introduce the non-right angle triangle, because it's not always that we are given the right angle triangle to find missing sides and missing angles. So I'll probably leave you with this to now work on and supply your answers. I'll have a gift for those who are actually going to get it. So let me have this. I have here 60 degrees. Let me put my x here and then write 12 here. Find x. So you see that this is also the second case we've talked about where you're going to use your SOHCAHTOA. I know you enjoyed the class. Continue to like and share our lessons to have a very wide, broader view for others. Thank you so much.